Okay, looks like we have a pretty good group that's come in. I appreciate everyone's time and thank you for joining our webinar this morning. This is our second webinar of 2021. My name is Jordan Novak. I am the Vice President here at R&D Technologies. Today we are going to be discussing optimization of 3D models using GrabCAD Print and Stratasys FDM printers. Today's presentation will be led by Colin Mulvey. Colin is an application engineer here at R&D. He's been here for 4 years, a tremendous asset to our company. And without any further ado, I am going to pass the baton over to Colin, who is going to walk you through some 3D models and some of the capabilities of Stratasys software and FDM printers.
Thank you, Jordan. Good morning, everybody, and thank you for joining us. As Jordan said, I'm Colin Mulvey. I am an applications engineer here with about 4 years of experience in the industry. I have a background in mechanical engineering from New England Tech, or New England Institute of Technology here in Rhode Island. So that's given me quite a overview, kind of in-depth review of all the things that I'll see inside of the industry, thanks to beginning here as an intern and seeing an inside look at the industry and how things seem to work for engineers. So as Jordan said, we're going to give a little run through of how to optimize your FDM parts in GrabCAD Print. I'll also give a brief overview of Insight, which is Stratasys's proprietary software, just to give a kind of a difference in terms of function as well as appearances between the two softwares for creating and sending your parts to machines in order to be printed. So without any further ado, let's get right into this. So I'm going to turn off my screen here and share my screen in which I'll be working. So here is the GrabCAD Print software. I guess we'll get this out of the way now. It is a free software that you can download straight from GrabCAD.com. GrabCAD.com is a website that is hosted for engineers in order to upload their files if they're working on a project and they want to upload files for other engineers to utilize, or if they're working on just a custom one-off project and they want other people to see what they're working on. You can just go right in there and download any kind of file that you want, or as long as it's available. So I've downloaded a couple things from there just to show different parts, different assemblies, different things that you can be doing and ways that we can optimize the prints in order for it to come out best appearance as well as the best function. So I'll set up my tray. This is our Fortis 450. That is one of the bigger box machines. It has a 14-inch by 16-inch X and Y and a 16-inch Z build height. It has all materials from ABS M30, which is a standard ABS plastic, and ABS M30i, which is for the medical field, and ABS ESD7, which is electrostatic dissipative. So if you have any assemblies with moving parts where you're housing electronics and you have concern over static discharge. We have ASA material, which is an ABS material that is UV stabilized so that it can stay outside and be in the UV light and not break down. Nylon 12, which is our basic nylon. It's well balanced between strength and rigidity, as well as its own flex, as you'd expect with nylon. Nylon 12 is the same thing, but with chopped carbon fiber mixed into the filament to add incredible strength as well as rigidity. Stratasys likes to use this material as a supplement for aluminums. We have a PC ABS, which is an ABS and a polycarbonate blend, a polycarbonate iso, which is a sterilizable polycarbonate, and then we have the Ultem family, Ultem 1010, which is very high temperature and strength, and on Ultem 9085, which is FAA certified and is more like ABS, where it's ductile and bendable. But like I said, it's FAA certified for non-flight critical components, components inside of the cockpit, dials, buttons, things of that nature. And then we have Intero 800 NA, which is for the oil and gas industry. It has very similar properties to Ultem, but it's very chemically resistant. So let's get into slicing a few files that I have here. So to begin, I have a little box, bit of an enclosure. So we can just see if we set it to ABS, standard slice height would be 10 thousandths. You can go really, really low for a nice looking part. It's going to take a long time to print. Or you can go with a 13 thousandths, which will print rather quickly. However, it's not going to look quite as good, but it will be a stronger part due to there being fewer layer lines. But the appearance won't be as well as a 5 thousandths layer height part would be. So going straight in, you can just drag your part straight in from any folder here. Here I have just a regular, Windows Explorer folder with 4 parts in it. You can just click and drag right into your build plate. And I guess we can start with what our best orientation for this part would be. So some people would think it'd be best to orient this way, but due to this pin right here being straight up and down, you have layer lines that are going to go straight across here, and that would be very susceptible to breaking. You'll also see that there's a pin in here that's going to cause this whole part to rotate and close like it's designed to do. And there's a gap between this pin and this enclosure here so that support material, sacrificial support material, can grow inside of that and then dissolve later in our post-processing tank. So we can rotate our parts or orient them on our build plate just by clicking and changing by its XYZ coordinate. So I can just change it in 90-degree segments, or I could type in, I want to change it to a 15-degree angle for some reason, or I could change it against its Y axis. So this is the optimal orientation to print this part in. That way you have the layer line going with the contour of the part, so that way it has its ability to bend as well as look really nice, so that you don't have what's called stepping, where the machine moves up its layer height and you'll start to notice what's called stepping. So it looks like a staircase going up that part if it was to be built like that in the build tray. If I orient this part over here and move this one next to it, and so if I had any issues with the parts, if they're missing geometry, if I converted it from a step file over to an STL and one of the geometries was missing, over here I would have a red exclamation mark, which indicates that there's a file error. I can click on that and I can view any files that do have errors. These files are clean and good, so I don't have any issues. But if I did, I'd be able to just repair it right in GrabCAD Print, which is a very nice feature. That way you don't need to bring it into any third-party softwares in order to fix your parts or bring it back into your CAD and see what's causing that issue. Most of the time, this is I'd say 9 out of 10 times, this repair fixes all. Like I said, there is that 1 out of 10 case where you do need to bring it into third-party software and fix it or figure out what happened in your CAD that caused that. So now that we know we have good files, we can return to the build plate, triple check that we have the right materials, layer heights, and then we can actually see how the part is going to build before we go to build it. You can see here, it's going to slice the model. It's going to break each part into its 10,000th layer height segments. Each one of those is going to be called a slice. And it literally just slices it in every 10,000ths in the Z height. So I can view all the model. So this is going to be model material in the green. In the yellow, that's going to be sacrificial support material. This is for any holes, any overhangs, anything greater than a 45-degree self-supporting angle. We'll need to generate support material. This support material, at least for ABS and ASA and the like materials, this is going to be using SR30, which is sacrificial and dissolves in our sodium hydroxide and water mixture. What we can do is we can view by layer. If there's a single layer of interest to you, you can go through and see, am I going to be able to just pick this support out without having to soak it. You know, I'm in a rush, I need to bring this into a meeting. Can I just break the support right off? Which it looks like this should be able to, and then you just be able to drill right through. But most people, you're going to take it off the build tray on the machine, take off as much as you can, put it into your post-processing unit, and then let it sit for about an hour, 45 minutes to 2 hours, take it out, put it in some fresh, clean water, let it rinse off all that sodium hydroxide. It was really just a strong soap, and then wash it off and let it dry, and then you have your nice parts. What I can do in here is, especially if I'm really trying to beat the time, so let me see how long this part will take to build. I can estimate it, and I can see that it's 1 hour and 6 minutes. You can also get your material consumptions and see how much it's going to cost in order to build this part on your machine. And like I said, you can see how it's going to build your sacrificial support along with the model. These yellow areas right here are what's called the seam. Just like with a CNC machine or a circle, let's just say, you're going to have the same point is going to be the start and the stop of that part or that area. These machines work the exact same way. So wherever it starts to build, it's going to come around, it's going to go around, and then it's going to stop in that same spot in order to finish what's called the contour. So this net outer shape is called the contour, and this internal is called the raster. And that's what is used to fill the internal of the part. We can change the infill. So I can have a sparse infill or a honeycomb and reduce the amount of material that is consumed by the machine. If I wanted to have a very light density, I could have 18% here. I could move it up to 100% infill density, so it's 100% dense, which would be this solid selection here. But with this infill, I can change it to I want about 50% dense, and I'd like the body of the part to be 0.1 inches thick. So this outer casing here would be 0.1 inches thick, and then the remainder, it would have, it would be solid, and then the internal remainder would be a sparse infill. So if I do a sparse infill, I hope this part is thick enough in order to do so. But you can see it will leave a little bit of an air gap inside of the part here. Actually, I have a better part in order to show just that. So if I select sparse on this part, this is actually what I use to turn my computer monitors on and off with their switches. So I can set it to a sparse infill with a 0.08 body thickness, and I can view how it's going to slice. So as you can see, it's self-supporting. There's no need for it to have any support material on this part other than on the bottom against the build plate in order to have a nice flat surface. And if I change it to a single layer view, you can see on the internal of the part that it has air gaps between it. So that's called the sparse infill. Each layer, the raster will switch to a 45-degree angle, and it switches 90-degree angles. Each layer will be opposite to one another, 90 degrees opposite. So say layer 166 here, they're going on a 45-degree angle to the right. Now they're going on a 45-degree angle to the left. This just increases the structural rigidity and integrity of this outer contour here. This is useful, like I said, for reducing your material consumption as well as reducing your print time. If you need a part very quickly, that doesn't need to be strong. You can just build it with the sparse infill. And let me show you just what the build difference is with this part here. It'd be a nice different speed. So with a solid infill, it's an hour and 8-minute part. And when I change this to sparse infill with an 18% infill density and an 0.8 body thickness, it changes to 55 minutes. Not significant, but when you look at the size of this part and the actual build time, 10 minutes is a fairly decent savings when you're trying to get into either a design meeting, or if you're working through different revs of a prototype and you want to make sure that the fit is nice or works well for your assembly or project. That's a good thing to definitely save time. I'll bring back that last part that I had in here and I'll get rid of this one. Because what I'd like to show is your ability to use model material as support material. So what we can do, as well as make a sparse infill to reduce time, is with this part, I wouldn't really be able to get a sparse infill because of both the size as well as the geometry of the part. It wouldn't really make much sense for the machine to do a sparse infill. So we'll make sure that we have model material, support material as selected, and we'll see what the build time is on this. So an hour and 5 minutes, pretty similar to the other part. And what we'll show is how the model material will build. So you can see it's only going to have support material on the very bottom against the bottom face in order for the model material to interface with. And that way it's not switching, because every time it needs to switch to sacrificial support material, the head needs to move over to its home, purge that head of the support that is sitting in the head, and then move over, draw out the support, move over, purge out the model material, and then resume printing the model. It needs to do that for every layer. So you can see we actually gained time. Now that doesn't always happen, but there are instances like that where it isn't so advantageous for the machine to actually switch back to the model material. So bad example, but it is a good mentality to have when building parts, of looking and seeing how material can build in order to reduce build times. Wish I had a better example for that, but we'll continue moving over with why we can build with model as support. So if I was building in nylon 12, which is a very heat susceptible material, and it likes to curl in the machine. So this little arm here would be a concern to me, meaning that if I was building support material up to here, there's something called the coefficient of thermal expansion, which every material will deal with, and it is at how much a material expands or shrinks in its environment dependent on the temperature. So the sacrificial support material and the model material have different coefficients of thermal expansion. So as the support builds up to here, it contracts a lot more than the model material does. So it won't have anything for this base to build on, and it'll cause this to curve up this way. What I like to do, and best practice to do when building a nylon 12, is to use model material where possible, as often as possible. That greatly reduces your curling and greatly improves your rate of succession when printing in nylon 12. So again, having just these 4 layers of soluble support material being here underneath this arm, and having this model material being the same coefficient of thermal expansion, greatly reduces the risk of this failing, as well as it happening up here with the support material inside. So this material, you can just pull right out, and then you'll just have this face of support that you'll have to soak in the soak tank, which you'll have to do with nylon anyway, since it is as in nature, it's a very wet material. In order to produce a filament, it needs to be dehydrated, and it needs at least 8 hours after printing in order to rehydrate, get to its correct dimensions, which is all accounted for. The shrinkages are all accounted for in the slicing software, so you don't have to worry about sizing correctly. But as I was saying, this nylon material, as well as our nylon 6 and our nylon 12, all need to rehydrate after printing in order to have their flex that nylon is known for. One other part that I'd like to talk about today is this fan blade. What we would like to do today is work into Insight, as I was speaking about in my introduction, is being able to rotate this part, but also being able to trust that it prints correctly. So we can rotate this part 15 degrees in the Y, actually that's the wrong axis. Rotate it 15 in the X. And that way I can have this be centered and make sure that each wave is across the axis in the correct direction. What we can do is we can just send it right to the machine like this. And it'll build a little bit of support underneath here. Depending on your material, again, if I was building this in nylon 12 or nylon 12 carbon fiber, I would probably use sacrifice model material as support. And we'll show what the build time is. So 2 hours and 12 minutes with regular support material. And if I was to use model material, knowledge or a little bit of knowing that it's going to print nice and clean, because what we can get to is a little bit of risk of all of this pulling out by itself. But the model material is a lot stronger than the support material and will stay solid to the base. What I would actually do in this instance is what we can actually do is click on apps and I can launch Insight. Again, Insight is Stratasys's proprietary software, which is used to, I believe in 2016 is when they, or 2017 is when they began to partner GrabCAD and Stratasys together in order to send straight from GrabCAD over to the machines. If prior to that, this is the only software that you were using in order to print. So again, we can just click on our parts and drag it right in. What I'll do is I will, oops, I don't have my boxes. Sorry. We'll do is I'll orient about 90 degrees that way. And if I want to just be a little bit more sure, this part should be just fine, but if it didn't curve quite as much over here and it was a little bit more straight, I would feel a little less secure about printing this part. I'd be worried about the machine going back and forth like this to fill in the raster, causing the part to wiggle a little bit, and you would notice that in the part. So what we can do is we can slice the part, and then we can add what's called a stabilized wall. So you would go up to a select layer. So I'll go about 50% of the way up. And that'll add this stabilized wall and mount it directly to the build plate. And every few layers, Let me try to orient this screen. It'll embed directly into the model. That'll keep it essentially bolted right down to the build plate and negate any movement of the part during building. So that will interface with the support material, interface with the part, and just add some secondary support to make sure that you get your part out as clean as possible. So as you can see, it will build through the support material here and interface with the part. And what we can even do is move it from Insight right back to GrabCAD. What it's telling me is I am using a processed file, which is what's comes out of Insight. And I currently have an unprocessed file, and you can't combine the two. So I will not save the current tray, and I'll allow the processed file to come in. It's going to use very low resolution in order to display your processed file. But if you'd like to review the layers, you can see each layer as it prints. You can view all of them. You'll notice that the graphics between Insight and GrabCAD are very different. GrabCAD is much more user-friendly, much easier to navigate through without knowing the ins and outs of additive manufacturing or exactly what it is that you're trying to do. So from here, if I'm happy with this part, I can send it directly to my printer. It's going to prepare the print. It's going to queue it up, and then you can see it in queue pop up. So now I can go over to the machine, press play, and I can have my part off of the machine in 2 hours, 17 minutes. One thing to note with this wall, stabilized wall, is it is manually removed, and it won't leave a burr, but it'll leave a witness mark. So it just pulls right off, and then this is dissolved. One last thing I would like to show is the ability to control the oven temperature. So I'm going to use this part one last time. Now, if I was to build this part in Ultem 1010, which is a very high temperature material, so it's able to be in environments of 421 degrees Fahrenheit. That's not the correct machine. So in order to do that, it needs to print at a very high temperature. If this wall was thinner than, I believe, 0.1 inches off the top of my head, then you would need to use this mode here, which is called thin wall mode. This reduces the oven temperature and will make sure that this part here doesn't become overheated, warp, or worse, melt. And that is something that applies to nylon material as well. With Ultem, you only have normal mode and thin wall mode, so it'll decrease the oven temperature, I believe, by 10 degrees Celsius. With nylon material, you have a brick mode. So if your part is thicker than 1/2 of an inch, your thinnest feature is greater than 1/2 of an inch, then you want to use what is called brick mode. This will increase the oven temperature and decrease curling of the parts so that it is at the correct cooling temperature for the parts to gradually cool down to the correct temperature and get their correct geometries or shape sizing after they shrink. Nylon also has a thin wall mode, which is great, which is less than, which I know is less than 0.1 of an inch for your thinnest feature. So that is certainly something you'd want to use on this part here, is thin wall mode. One last thing that I'd like to show is this feature called a sacrificial tower. We use this on every one of the parts that every single one of the projects or builds that we print on our machines. This is the first part of every layer that is printed in order to guarantee that there's nothing on the tip, there's no oozing, there's no burn marks or anything in the part. It'll be deposited in this as it's the first part that is built on the build tray. So we use that on every single part. It just guarantees a nice clean part. No strings or stringers will be left hanging off of the part. No burn marks or any burrs or anything like that. Jordan, do we have any questions in the Q&A?
We do, and what we'll do is we'll address these questions, and then I'll also open up I'll call it the lines to use as an old term, but I'll allow.
I'm sorry, you cut out on my end.
To be able to talk. So, Colin, first question, when you were discussing the first set of parts is you were discussing using soluble support in that particular part. Which materials use breakaway support material?
Good question. That is something I actually wanted to go over. So breakaway support material is used on polycarbonate. It also has a soluble support material, but if you're going to use polycarbonate iso, you can only use the breakaway. Ultem 1010 and 1010 certified grade, as well as the 9085 and the Intero family, are all breakaway. So polycarbonate has breakaway and soluble. It's dependent on what layer height. So if you're using 5,000ths layer height, you can only use a soluble layer support material. Anything above that, you can use your breakaway if you'd like. Other than that, with polycarbonate, it is preference soluble or breakaway, depending on geometry. But you'll be using breakaway only for the Ultem and Intero families.
The second question that came in, Colin, are there any advantages in slicing parts in Insight versus GrabCAD? And are there more features in Insight when slicing the part more in depth?
There are certainly a lot more features in Insight. Like I had said, GrabCAD is the user-friendly software. It has a nice display. It has, the necessities of what you'll need in order to slice and send your parts to your machine. Insight has full control of your part. So I'll show you here. You have the ability to create custom groups that apply to layers that you apply it to. So you can do anything and everything. You can apply multiple contours to those groups. You can change your contour width. You can change your raster width to be thicker, thinner. Again, that can increase your build time. It can decrease your build time, all depending on what you want to do. If you want to have a air gap or a negative air gap so that the part is watertight. If you want to have a positive air gap so that it has, you can force a sparse infill. You can certainly do that. You can link the contours so that it doesn't have a seam. It does one circle and then it'll move in and almost create a spiral for the contours. So yes, there are certainly many advantages to printing in Insight. I wouldn't necessarily say it's necessary to print through Insight. A lot of the times I'm actually just printing customer files through GrabCAD. I don't see it necessary to go through Insight unless I need to create a custom group or if I need to create a stabilized wall. A lot of times when we're doing thermoform molds, we'll create a custom sparse group in here. So we'll include in part sparse fill and we'll apply it to the bottom 5 layers, which are usually solid as sparse part. We'll apply it to that so that it is a complete open waffled bottom. That way, when the customer puts it on a vacuum table, it pulls as much air as possible through the part. So to answer the question, Insight has a lot more, is jam-packed with features, things that I've never even touched, never needed to use, but is there for to my ability to use.
So at this point, I'm just going to open up everyone's line to be able to talk. If you have any questions or you want to discuss anything with Colin directly. If you don't, we just ask you to please mute. And as we go through that, we had one more question, Colin. What do you recommend to build more often, in ABS or ASA, and why?
I try to use ASA as often as possible, just for the fact that it is a UV stable. So even if you don't plan on taking it outside, we have parts in our back room that we use day to day that are made out of ABS before ASA was created. And just from light coming through the windows, they've begun to yellow. It's not only an appearance concern, it is a function and mechanical property concern. So the UV actually breaks down the mechanical properties of the ABS. It becomes very brittle and no longer ductile or bendable. So I try to build in ASA as often as possible, unless ABS is explicitly requested by my customer.
At this point, does anyone have any questions they'd like to talk live with? Okay. We also had another quick question come through. How do you recommend cleaning Ultem parts? I know that's your favorite.
I definitely recommend wearing a glove. These parts are pretty hot. They're coming out of a 400-degree oven. We use a set of picks. I'm not sure what the original intent was of the parts. I think that they, sorry, of the picks. I believe that they're not clay tools, but they are steel tipped. I'm not entirely sure. That might be scribe picks, but they're very high, heavy duty, and we just use those as well as shears, snips, flathead screwdrivers, really any kind of tool that will work for you. I recommend using as much plastic tools as you can in order to not mar the surface that you're working with. A nylon or a rubber coated pick would work really well. Eye protection works well. As you're picking parts, the support material is very brittle. It breaks away and it shatters, and little bits fly everywhere. I recommend picking these parts when they're warm. If you take it out of the oven and you're picking it and it's a rather big part or an intricate part and you need to pick it for a while, I'd recommend, as it starts to cool down, the material starts to get a little less easy to work with. So we just put it back in the oven, let it heat back up, and then we're able to work with the support material again.
Are there any more questions out there?
I'd just like to note that if anybody, any of our participants have any questions or have an application that they'd like to go over one-on-one with either myself or one of our other applications engineers, or just with the team, if you have a project and you'd like to go over it, either over Zoom, or if you'd just like to converse through email or over the phone, please feel free. That's what we're here for. We like working with our customers. We like talking through projects. We like seeing, how the project works and what material you're currently using, material woodwork that we have in-house, what process works. Feel free. That's what we love to do.
And Colin, thank you very much. This is a great presentation of the capabilities that R&D currently has. Again, just as Colin stated, if you have any questions that are not addressed here today and you'd like to email us, please feel free to do so. The email address is 3dparts@rndtech.com. And also stay tuned for some new capabilities coming down the line with our website. We have an online quoting tool that will be launched at the very beginning of the second quarter to be able to get quotes online, be able to book time with our sales representatives if you're interested in machine sales, and you'll be able to book time with our applications engineers. And this is all coming in the second quarter. So we've got a lot of big things coming down the pipeline here at R&D. We thank you very much for your time and attendance of our webinar. And please feel free to reach out at any point in time if you have any questions. Thank you.